Good morning, viewers. This is Kasturi Day. Sorry, I am late of this. I have to complete this chapter because I was having fever. Sorry, I could not complete it in time. Okay, you can understand from my voice also. Still, my voice is choked a little bit. So let me start with the numericals. Question number 31. I will continue with. And before that, I will request you to please do subscribe my channel. And also, if you are liking the videos, press the like button and share with your friends, and so that they can also be benefited from this video. And also, do not forget to meditate before starting your day. Okay, this will help you a lot in your studies, in your work, what you do. Okay, so please concentrate on meditation first, and then you can automatically go on to studies. Okay, and you can get success also. So let us start with first with the numericals. So first is the following table gives the displacement of a car at different instance of time. See, time. Second, it has been given as zero displacement. When the time is zero, displacement is 0 meters. And when time is 1 second, displacement is 5 meters, 2 seconds with 10 meters, 3 seconds, 15 meters, and 4 seconds with 20 meters. So the question is, draw the displacement time sketch and find out the average velocity of the car. What will be the displacement of the car at first is 2.5 seconds and 4.5 seconds. So first one will be, the graph will be like this. At 2.5 seconds, it will be 10, between 10 and 15 in the middle bit. And when it is 4.5 seconds, and then it will be beyond 20. So this will be the graph like this. And since the displacement time graph is a straight line, velocity is uniform, and the average velocity of the car, which will be equal to the instantaneous velocity, that is the slope of the graph. Okay, that will be equal to total distance by total time. So total distance will be 20 minus 0. Total is 20. The final velocity, final displacement is 20, and initial displacement is 0. So 20 minus 0, and time will be 4 minus 0. So 4 is the final time, and the starting time is 0. So 4 minus 0. So the difference between the time displacement and time, that will give us to 20 by 4, that will be equal to 5 meters per second, will be the average velocity. Okay. Now, next question, part B. When the graph is observed, the displacement of a car at various points will be at t is equal to 2.5 seconds, the displacement is 12.5 meters. Okay. So when t is 2.5 meters, 2.5 seconds, then the displacement will be 12.5 meters. Okay, and when it is 4.5 meters, 4.5 seconds time, the displacement will be 22.5 meters. Okay. Now, next question: a boy is moving in a straight line, and its displacement at various instants of time is given in the following table. See, 0 seconds, 2 meters, 1 second, 6 meters, 2 seconds, 12 meters, 3 seconds, 12, 4 seconds, 12, 5 seconds, 18, 6 seconds, 22, 7 seconds, 24. So plot the displacement time graph and calculate the total distance traveled at in intervals of 1 second to 5 seconds, and average velocity, the time interval of 1 second to 5 seconds. See, according to the table, so time when it was 0 seconds, the displacement was 2 meters. Okay. So time axis, this is x-axis, and y-axis is displacement. So 0, it will be 2. Then when it is 1, it is 6. Okay. And 2, it is 12. 3, it is 12. 4, it is 12. So it becomes static here. Okay. So there is no displacement here. 12, 2, 3, 4, there is no displacement. Then again at 5, it is 18. It moves on to 18. Then 6, it moves on to 22. 7, it's 24. So according to the graph, the total distance in intervals of 1 second to 5 seconds will be 18 meters minus 16 meters. That will be equal to 1 second to 2 seconds. So 1 second, it will be 6 meters, and 5 seconds it is 18 meters. So 18 minus 6, that will be equal to 12 meters. The average velocity, total distance by total time. So 18 minus 6, 5 minus 1, that will be 12 by 4, that will be equal to 3 meters per second. Okay. So the following figure shows the displacement of a body at different times. Okay. So this is the figure. This, you can see the displacement of the body, moving body at different times. Now calculate the velocity of the body as it moves from the time interval 0 to 5, then 5 to 7, then 7 to 9. So 0 to 5, displacement, it becomes 3 meters. Then 5 to 7, it's again 3 also, 3 only. And then from 7 to 9, it is rising to 7 meters. So, okay, then calculate the average velocity during the time intervals of 5 seconds to 9 seconds. Then first we need to calculate the velocity. Now, so velocity is equal to displacement by time. So from 0 to 5, it is 5 seconds. Okay, and displacement is 0 to 3 meters. So that is 3 meters. So 3 by 5 will be the answer, or you can say 0.6 meter per second. So this is for 0 to 5 seconds. Now from 5 to 7 seconds. From 5 to 7 seconds, there is no displacement because the displacement is showing 3 meters throughout. So it will be 3, that will be 0. So no displacement, that means 0 by time taken is 7 to 5, that's 2. So that means what? 0 meter per second will be the velocity. Now when the time is 7 to 9 seconds, here the displacement is from 3 to 7. Okay. From the graph you can see it is rising from 3 to 7. Okay. So it will be the displacement will be 7 minus 3, and the time taken is 7 to 9. That means 9 minus 7. That means what? This will be 4 by 2, or you can say 2 meters per second will be the velocity. Now average velocity, total distance by total time. So from 5 to 9 seconds. Okay. So from 5 to 9 seconds, we can see its time is, what total time has been taken is 4 seconds, and the total displacement is from 3 to 7. So that means 4. So 4 by 4, that's 1 meter per second. Now next question, from the displacement time graph of a cyclist given in the following figure, find the average velocity in the first 4 seconds and the displacement from the initial position at the end of 10 seconds, the time after which he reaches the starting point. Okay. So this is the figure. Okay. So see, it is moving in this way. First, it's when it is 1 second, it is moving to 5, then it's 10, then from C to D, it's again 10. Then it's coming down, okay, to 7. When it is 7 seconds, it's coming down to the original position. Then it is moving down to F, then to G, then to again rising up to H. So this is the figure. Now we need to find the average velocity in the first 4 seconds, that is 1 to 4. So total distance by total time. So 4 seconds is the time, and total distance is what? 10 meters. Okay. And so 10 by 4, that's 2.5 meters per second. Now from the graph, next question, the displacement from the initial position at the end of 10 seconds. At the end of 10 seconds, 10 seconds is here. That means the first the body has moved from A to B to C to D, then come to E, then again to F, then it's moving on to G in the time of 10 seconds. Okay. So what will be the final minus initial position? Displacement will be 10 minus 0, that's 10 meters. Okay. Okay. From the graph, it is 10 meters now. minus 10 meters rather. Okay. It's moving to minus 10. So it's coming down, no? So it's minus 10. So it's from the graph, we can see it's minus 10 meters. From the graph, next question, that is the time up to which he reaches the starting point. 2 points he has reached the starting point. One is at 7 seconds, another is 13 seconds. So from the graph, it is indicated the cyclist would reach the starting point twice, at one at 7 seconds, another at 13 seconds. Now, next figure shows the velocity time graph from the motion of a body. Use it to find the displacement of the body. When t is at 1 second, 2 seconds, 3 seconds, and 4 seconds, then draw the displacement time graph from it on the figure B. Okay. So this is the figure. According to the graph, we can see the velocity at 1 second is 1 second. 2 seconds is 2 meter, 2 meter per second. 1 second, it will be 1 meter per second. 2 seconds is 2 meter per second. 3 seconds is 3 meter per second. 4 seconds is 4. By the displacement here, it will be velocity into time. So that means what? When it is 1 second, the displacement will be 1 into 1, that will be equal to 1 meters displacement. Then when it is 2 seconds, the displacement will be 4 meters. When it's 3 seconds, displacement will be 9 meters. So the graph will be like this. It will be like a parabol. Okay. Like this. If you point the graphs on the graph paper, this will look like this. I pointed it on the graph paper, okay, that will make it easier to understand, okay, how to point it. Next is a ball moves on a smooth floor, okay, in a straight line with a uniform velocity 10 meters per second for 6 seconds. At t is equal to 6 seconds, the ball hits a wall and comes back along the same line to the stretching point with some speed. Draw velocity time graph and use it to find the total distance traveled by the ball and its displacement. Okay. So this will be the x-axis, the time axis, and velocity will be this axis. Now, from the graph will be like this. Velocity will be 10 meters per second, then it will come down, reach the starting point, and it will go down, and again it will be becoming static. So like this, the velocity time graph on the motion of the ball, the smooth floor will be a straight line, which is shown in the figure. So the total distance traveled will be distance traveled in the first 6 seconds by distance traveled in the plus the distance traveled in the next 6 seconds. Okay, so the next first 6 seconds will be a straight line, then it will be the next 6 seconds. Add this, then you will get the distance, total distance traveled. Now, d is equal to d to t. We know that substituting the value in the formula, we get distance when the ball moves towards the wall. 10 into 6, that's 60 meters. Then distance when the ball is moving away from the wall. 10 into 6, that is 60 meters again. Distance will be no negative sign. Okay, displacement, if it was displacement, then it will have the negative sign. The total distance will be 60 plus 60, that's going to be 120 meters. The displacement will be what? 60 minus 60, because it's coming down, reaching the starting point, and then it's going down. It's retarding, and then it is moving on to the negative side. So moving towards the wall. So it's moving, the displacement is reverse. So that will be 0 meters because it's reaching to the starting point. Comes back to the initial place. Now, figure below shows the velocity time graph of a particle which is moving in a straight line. So this is the figure. It's moving like going up velocity and then it's coming down. Okay, state the nature of the motion of the particle, find the displacement of the particle when t is equal to 6 seconds. Does the particle change its direction of motion? Compare the distance traveled by the particle from 0 to 4 and from 4 to 6. Find the acceleration of 0 to 4 seconds and retardation from 4 to 6 seconds. Now, according to the graph, the nature of the motion of the particle is the particles are uniformly accelerated from 0 to 4 and then uniformly retarded from 4 to 6. Okay. So from the graph, it's moving up, that is, it's accelerated, uniformly accelerated. Then it's again uniformly retarded when it's coming down from 4 to 6. Now, at the displacement of the particle can be obtained by finding the area enclosed by the graph. The enclosed figure, that is the triangle which we see in the figure, if we find out the area, we can get the displacement. So, but from the graph, then that will be at t seconds. T is equal to 6 seconds. The displacement of the area of the triangle will be half into base into y. That will be equal to half into 6 minus 0 into the seconds and time. And the displacement, I mean the velocity will be 2 minus 0. That is 6 into 2. Half into 6 into 2. That will be equal to 6 meters into the displacement. Okay. Now, no, the particle does not change the direction of the motion. Okay. It will not change the direction of the motion. And when at t is equal to 0 to 4 seconds, the distance covered will be again area of the triangle, half into 4 into 0 into 2 into 0. Okay. So half into 4 into 2, that is 2 minus 0 rather. It will be 4 meters. And at t 4 seconds, when t is equal to 4 seconds to 6 seconds, distance covered will be half into 6 minus 4 with a seconds time. And displacement will be, I mean, velocity will be 2 minus 0. Okay, so half into 2 into 2, that is 2 meters. So the total distance covered will be 0 to 4 seconds will be distance covered between 0 to 4 seconds will be distance. These two distance covered between the 4 seconds to 6 seconds. So 4 into is to 2, that is 2 is to 1. So the comparison between 0 to 4 seconds and 4 to 6 seconds, it will be 2 is to 1. Now, acceleration is in part 0 to 4 seconds will be the slope of the graph. The slope of the graph is 2 minus 0 meter per second by 4 minus 0 seconds. That is 2 by 4 are equal to 0.5 meter per second square. Now, negative acceleration, as it is retarding, it's moving up. That's acceleration 0.5 meter per second, and it is coming down, uniformly retarding. Then it will be 0 minus 2 meter per second and 6 minus 4 meter per second. So that will be equal to minus 2 meter per second by 2 seconds. So that will be minus 1 meter per second, or retardation you can say 1 meter per second. Or if you write acceleration, then it will be acceleration is equal to minus 1 meter per second square. Now write an expression for the distance s covered in the time t by a body which is initially at rest and starts moving with a constant acceleration. Okay. So according to the equation of motion, we know that s is equal to ut plus half at squared. As the body is at rest, so its initial velocity u will be equal to 0. So s is equal to 0 into t plus half at squared. Okay. So 0 into t will be what? 0 plus half at squared. So 0 we can omit because 0 has no value. So s is equal to half at squared. Clear? Next, some more numericals we move on to. A body starts from rest with a uniform acceleration of 2 meters per second, but the distance covered by the body is 2 seconds. It starts from rest, so 0 u is equal to 0, acceleration is equal to a into 2 meters per second square, and t is equal to 2 seconds. So s will be the distance covered. So according to the formula, ut plus half at square, as u is equal to 0, so ut will be equal to 0 plus half at square means half into acceleration 2, so 2 into 2 square, that is 4 meters. Will be the distance covered. Okay. Now, a vehicle is accelerating on a straight road. Its velocity at any instant is 30 kilometers per hour. After 2 seconds, it is 33.6 kilometers per hour, and after further 2 seconds, it is 37.2 kilometers per hour. Find the acceleration of the vehicle in meter per second in the acceleration uniform. We need to find out. So as a is equal to, we know, v minus u by t. After t is equal to 2 seconds, then we know initial it is 30 kilometers per hour, or 30 into 5 by 18, that is equal to 8.33 meters per second. Okay, and final velocity, we know it is 33.6 kilometers per hour. Okay. if it is 33.6 kilometers per hour, that means equals to 9.33 kilometers per second. Okay. So acceleration will be 9.33 minus 8.33 by 2, that is 1 by 2, that is 0.5 meter per second square. Okay. Next is for the next 2 seconds, u is equal to 9.33 meter per second and v is equal to 7.2 kilometer per hour, that is equal to 10.33 meter per second. Again, a is equal to v minus u by t, that means 10.33 minus 9.33 by 2, that is half, that is again 0.5 meter per second square. So acceleration is uniform, we can find out. Okay, so acceleration is both instances are same, therefore it's a uniform acceleration. Next question is a bullet initially which moves with a velocity of 20 meters per second strikes a target and comes to rest. After penetrating a distance 10 centimeters of the target, calculate the retardation caused by the target. Okay. So according to the equation of motion, v is equal to u square plus 2a, u is equal to 20 meters per second, v is equal to 0, s is equal to 10 centimeters, that is 0.1 meter. Substituting the values of equation, 0 is equal to 20 square plus 2 into a into 0.1, that is equal to 400 plus 0.2a, that is equal to minus 400. You can calculate also, that is a is equal to minus 2000, that means it is retarding with 2000 meters per second square. Okay, retardation. So I think I'll stop here. I'll discuss the next part of the remaining chapter, remaining questions rather. I will discuss it tomorrow and finish the chapter. Okay, and I'll move on to the next subject, that is biology. Start the next chapter. So please. If you like the videos, press the like button and share with your friends. And if you have not subscribed yet, please do subscribe to get the notification of my next video. And please don't forget to meditate. Okay. And you can also access to my email ID, that is kasturi74@gmail.com. Thank you for watching and have a good day.